Over the years of me teaching, I have come across dozens of students who weren't able to clear their competitive exams because of one silly thing. They just couldn't attempt the math section at all. I ended up hearing things like, I just couldn't solve it, or I just couldn't understand the question. The question looked so complex. I just thought it's better to leave it. Well, these are things that can easily be worked around. How do you do this? In today's video, I'm going to give you a chapter-wise breakdown of learning math in your first round of revision. Once you're able to figure out your first round of revision, you will be able to actually grasp the kind of questions that come in your competitive exams and actually ace them on D-Day. So, how do you clear your basics? That is what I'm going to do in this video. So, let's get going. Firstly, let me start with sets, relations, and functions. This is the chapter wherein you need your concepts to be crystal clear. What are sets? What is a relation? What are the kinds of relations? What is a function? What are the kinds of functions? What is domain? What is range? What is codomain? If you have answers to these questions, you are set for your entire math journey. If you are not able to answer these questions, understand them by visualizing them. So draw Venn diagrams. Draw those mapping diagrams that map functions from its domain to the codomain. Understand by visualizing. So once you're able to grasp these concepts, move into trigonometry. It is the exact same thing. I just don't know why are people so afraid of trigonometry. They don't understand that it is the exact same thing that you'll be doing with regular sets, relations, and functions. It is just a type of function. So understand trigonometry like any other function that you would go with. So understand the domain of those functions, the range of those functions, and the properties that come with it. You have around 50 odd formulae that these classes and these textbooks give you. Never learn those formulae. If you know the properties of the trigonometric functions, you will be able to derive them on the spot. This is true for almost every single formula or derivation that comes in math. These are the basics. The rest of your math builds up on it. Next, move on to complex numbers. Think of your complex number as just one number with two parts, one being the real part and one being the imaginary part. What are you supposed to exactly deal when you're taking care of this? Understand how do you add, subtract, multiply, divide. What are conjugates? What are inverses? All of those concepts need to be clarified. Once you get a grasp of these concepts, complex number is a breeze. And also understand the geometrical application of this. Understand the Argand plane, or what Indian teachers like to call as the Argand plane. Understand that. Understand how you can visualize these complex numbers. This way, the complex number is done for. Moving on into matrices and determinants. These are such handy tools when it comes to understanding math. And these can seem very daunting at the start. So what I usually suggest people to go for their first revision, I suggest them to focus on this part quite a lot. Understanding how to deal with 2x2 matrices, 3x3 matrices, understanding addition, subtraction, multiplication, division, transpose, inverse, and understanding how to take out a determinant. Understanding real life applications of these matrices. Matrices are used to solve systems of equations. Understand how to do that. And also to build up more interest, understand how it is used when you are coding. The key here is to practice. Keep on practicing till you're comfortable solving any kind of matrices so that you don't have to feel afraid of it anymore. Now that we have an idea of how functions work and you have taken care of your basic algebra, move into limits, continuity, and differentiability. These three concepts can only be understood if you have understood how functions work. Understanding the limit point of a set, understanding limits of a function, understanding how continuity works, how continuity looks on a graph, understanding how differentiability works, understanding how that looks on a graph. Understand, visualize, practice. This is the way you go with it. After you have understood differentiability, you can understand differentiation in its entirety. So this was me talking about differentiation from the first principle. Then you move on into other calculus related tips and tricks. Understanding chain rule, UV rules, U by V rules, quotient rule as you call it. Understanding standard formulae and practicing those standard formulae. Do not rote learn this. Practice hundreds and thousands of questions if you want. But this is the way you're supposed to learn these standard formulae, not by sitting and writing them 20-30 times. Once you're done with differential calculus, move on into integral calculus. It is nothing different. Differentiation and integration is linked by the fundamental theorem of calculus. They are directly interlinked with each other. Understand the real-life applications of both differentiation and integration. Understand what is their significance. Then you can actually move on into mathematical techniques for solving these kind of questions so that your concept base for calculus is set. Move on into techniques like your power rule, integration by parts. Practice these kind of questions. This will solidify your concept base for calculus, and then move on into differential equations. Understanding how to solve them, variable separable method, linear method. Understand where these come from and understand their applications in real life. This is the way you will actually start appreciating math a lot more. Let me bridge algebra and geometry by introducing coordinate geometry. A lot of it is revision from your 9th and 10th grade apart from your conic sections. Understand how these equations behave. Conic sections are not something to be afraid of. They are equations. They're literally equations plotted on a graph. Understand how these equations have come out. Understand their significance. Appreciate the manipulations that you can make to those equations to get your desired results. The more you appreciate, the more you understand. So understanding the geometric significance of tangents and normals help you bridge this to calculus as well. So this got us into geometry. Now that you have taken care of 2D geometry, let's bring this to 3D. Understanding equations of lines, planes in 3D, and understanding how volume and surface area are dealt with in these chapters, and practice finding those angles between those lines and planes. This gives you a concept base for real life applications. I can understand that visualizing in 3D is difficult, but well, that's why you have computers. You could just put in an equation on a math editor and actually get a 3D graph for it, right? This makes understanding 3D geometry a lot more easier. And there you have it. All of your math can be taken care by firstly understanding the basics, visualizing the basics, applying the basics in real life, appreciating the basics, and then solving beyond the basics. This 5-step method will help you ace math in your first round of revision. Go beyond that and you're set for your competitive exams. If you like this video, make sure to hit the like button, subscribe to the channel, and follow for more tips. Also, if you're interested in working with me one-on-one on your study guide on understanding how to study in your specific case, I'm offering a free 30-minute session to grades 9th to 12th. The link to that Google form is in the description down below. Make the most of it. So, with this, thank you and happy learning.